All right, so for this unit, okay, we start, I'm just going to go in order, okay, start right from the beginning. So very first day, we reviewed scalar versus vector quantities. Okay, we reviewed the use of V equals d over t. Okay, we looked at, difference between velocity and speed, distance, and displacement. Are you recording? I am recording this. Yep. Okay. All right, so we went over all of that stuff, but that was all review of Science 10. Okay, the scalar quantities that we have, time, distance, speed, we didn't talk about some of these ones, but they are scalar, energy, and work. Okay, they'll actually be a bigger part of the next unit. Okay, vector quantities, displacement, velocity, acceleration, and force, which will be part of the next unit. It's not important for this one. Okay, and then, like I said, we talked about V equals d over t and V equals d over t. Are they different? Yes. Okay. In this one, the first one without the arrows over top, okay, this is speed equals distance over time, total distance over total time, if we're talking about the average velocity. Right? And then for velocity, the V with the arrow over top, okay, we're talking about displacement divided by time. Okay? And if we're talking about average velocity, that could be our final position minus our initial position, or total displacement, okay, divided by total time. Right? This formula is a bit more important if we're dealing with a position versus time graph. All right, so where is that going to be on your unit exam? Well, I'm not going to waste a 5-mark written response question on V equals d over t. Okay, you're past that. I'm not going to do that. However, there could be some simple V equals d over t calculations in a multiple choice question. They could also be part of a graphing question if it was a, either one of the graphs really that we dealt with, position versus time or velocity versus time. And obviously, it's part of projectile motion, which we've been working on the last few days, with a horizontal component of either horizontally projected or angled projected projectiles. Okay, so it's going to be in there in those places. It's not something I'm testing specifically, but it's part of a lot of other things, so you need to make sure you know how to do it. All right, the next thing that we went over, graphing. And that was all review of Science 10 as well. Okay, we went over position versus time graphs and velocity versus time graphs. You're going to be asked to interpret those types of graphs and perform calculations using them. So an interpretation question could even be in the multiple choice. Okay, it could say, using the graph below, what type of motion is being shown? Okay, and maybe it shows a position versus time graph with a curved line going up, right? And you would have to remember that that means that the amount of distance covered every second is increasing, and that means the object is going faster and faster. Thus, it would be an accelerated motion that's being shown in the graph. That's an interpretation type of question. Okay. A calculation type of question could be a written response item where I show you a graph and ask you to calculate the average velocity over a multi-part trip, or I give you a position versus time graph that's one linear function with y equals mx plus b, and ask you to calculate some other things to do with that. Okay, so it could be one or the other, okay, along those lines. Right, and then obviously we talked about velocity versus time, and we talked about y equals mx plus b. Okay, how we use that, what it can get us on both types of graphs, and you'll be tested on that. Both graphs are in both sections of the test. Okay, so there's some velocity and position versus time graphs in multiple choice, and there's a velocity versus time graph question in the written, and a velocity versus time graph question in the written as well. Okay, and positions are in there. So there's one of each in both sections. Okay, things to remember. All right, if I'm looking at a velocity versus time graph, like the one here on the left, okay, what is this showing? Oh, I'm crushed. I was really hoping for an enthusiastic, immediate answer about how that's showing an object that is accelerating. I don't care what day it is, you need to know that like this, okay? It is showing an accelerating object. Is that something I needed to memorize? No. I should look at this graph and go meters per second on the y-axis, seconds on the x-axis, and an increase or change in velocity. What's a change in velocity? That you need to memorize, but that's what you use to figure out what's being shown. You don't have to memorize all the shapes. You have to interpret the shapes. That's an interpretation question. Okay? Now, I could also ask, using this graph and the equation given, calculate the, or tell me what the acceleration is. How many marks would that be on? 1. Why? Right? It's right here. This was part of our lab. Okay? The acceleration of an accelerating object is the slope of a velocity versus time graph. Why? Not something you need to memorize, just something you need to analyze. Acceleration is VF minus VI over t. Change in velocity over time. If I calculate the slope of this line, y would be my final velocity, b would be my initial velocity, and x is time. I feel like I'm teaching this. I look at you and feel like I'm teaching this for the first time, even though I know I'm not. Okay. Is that making some sense? Now, another thing I might ask you to do is calculate the total displacement. How do I do that? Area under the line, yeah, okay? There's two ways to go about doing that, okay? I could use y equals mx plus b to figure out how tall the line goes up to 10 seconds, and then calculate the areas of the shapes. Or I could be even more clever and use this formula, which does the same thing. Right? VI times t is this number here times this number here, which would get me the rectangle, base times height. Okay? And this part here calculates the triangle. And all the numbers you need are here in this formula, right? Because this number is A, this number is VI, and t is 10 seconds. Right? I'd be able to use that formula and not have to do anything else. Right? These are all things that we'll have to obviously review a little bit, okay, over the next week or so, if we're preparing for this test, because I'm pretty sure I'm going to ask that. Since I'm the guy that made up the test, I'm probably going to ask that. By probably, I definitely. Okay, and we could also have a position versus time graph. Now, the position versus time graph could probably show a linear relationship, but I would doubt I would do that twice. So one of these graphs is going to be irregular and the other will be linear. Okay, I'll tell you that right now. But using y equals mx plus b is the same regardless of what kind of graph you have. It just calculates different things. Okay, so for a position versus time graph, if I asked you, what's the velocity of the object? That'd be 1 mark because it's right there. It's the slope of the line. Okay, things like that. We got to remember what all that stuff is. Okay, or I could give you a position versus time graph, maybe that looks like this. Okay, and ask you what's the total displacement or what's the total distance traveled. Okay, all those things that we did in class. Okay, that we should be familiar with. Okay, from that stuff. Okay, so I'm not going to ask you to do anything new or anything I haven't taught you. Okay, I'm going to ask you to replicate all the things we've already done. Okay. All right, questions on the graphing? There's a fair amount of marks to do with graphing, so I would spend some time on that. If I'm planning my studying, that's what I would do. All right, after that, we went on to acceleration. There are some acceleration problems, okay? In both the multiple choice, those ones will be very simple, okay? And written response. So make sure you can use your acceleration formulas. Okay, also, a question people often ask, can I have my formula sheet? No, you must memorize all the formulas. Not really, no. Okay, you can't have your formula sheet, but I did put the kinematics section of the formula sheet on the front page of the unit exam, so all the formulas you're used to having will still be there. You don't have to memorize any of them. Okay, don't memorize the formulas. Capital letters don't. All right, so you got to do some problem solving with acceleration, and there's some questions in the multiple choice about the nature of acceleration, what it is, stuff like that. All right, then vector addition. There are 2 vector problems in the written response section. Okay. One is a vector component addition question. Okay. Like we've done tons of, okay, find the x's and y's, get the resultants, okay, that kind of thing, and a boat question. Okay, there are 2 kinds of boat questions, remember? One where you're rowing across and one where you're going across. I shan't spoil which type it is, okay? But I'll tell you there's a boat question, okay, on the test. Right, so remember that all vector addition is done in the same way. Tail to head, right? And the vector addition question, the vector component question is just like I told you it would be. One of the lines is either horizontal or vertical, and the other line is angled. Okay, so you have those 2 vectors to add together, okay, to get your result. Right? So remember that you could have the 2 types of boat questions. You may have one where you're rowing across, and the current is carrying you downstream, so as a result, you move at an angle downstream. Question might ask you, what's your resultant velocity? Okay, and it might also ask you if the river's a fixed distance wide, how far downstream will you be when you get to the other side? Exactly like what we did in class. Okay. One thing to watch for in the boat questions, regardless of which type, is if the question asks for a specific reference direction. Okay, what I mean by that is I could give you a question like this and say, you're rowing across a river due north. What's your resultant velocity expressed relative to due east? Okay, so that means find this angle here, because that's the one that will be north of east, referring to east, rather than this one, which would be referring to north. It would be east of north. Okay, so if it says relative to due north, it's something of north. If it's relative to due east, it's something of east. Okay, sometimes a question will ask for specific angle. Okay, so in that case, there aren't 2 correct answers. There's only one. Okay, if the question is about going across, then it will tell you, you can row this fast, the green line, okay? The current is going this way, this fast, and you end up going straight across the river, and that question would really only ask you probably one thing, and that would be, what direction are you headed in? And that would mean finding that angle there, okay? The one that you have to row at in order to end up going straight across, given how fast you can row and how fast the river is flowing. Right? Those are the only 2 types that we've gone over, thus it'll be one or the other on the test. And then projectile motion. There's one of each in the written response, and a couple of questions about it in the multiple choice. No calculations in the multiple choice, okay? But there's a horizontally projected projectile, it's question number 1. And projected at an angle projectile, it's question number 2 in the written response. Okay, and they are both nearly exact copies of ones we did in class. And by nearly exact, I mean literally that. I changed a number. Okay. So it might be worth your while to look over the examples we did. Would be the thing I'm saying. I'm being very direct. Now, in terms of multiple choice, part of the exam is multiple choice. In case you catch that. Okay? Part of the exam is multiple choice, and part of it is written. All right. The multiple choice will be done on the zip grade bubble sheets. Okay, that pretty much everybody uses now. Please remember that on a zip grade bubble sheet, it does not understand if more than one bubble is filled in. Okay, so my recommendation to you is that when you're first going through the multiple choice, maybe just do this, okay, to start with, or maybe just like put an X, a really small X in, and then when you're sure, come back and fill it in completely, all right? Because if you don't erase it fully, my phone will think you've got 2 bubbles filled in. Okay, so you need to make sure that only one bubble is clearly filled in on each line. Okay, please, for the love of Pete, do not do this, because this is what I see people do all the time, and it's just like sheer laziness. Okay, it's like, all right, it's totally A. Oh, nope. No, it's not A. It's C. Oh, no, wait. It's that implies that I'm looking at your bubble sheet. I am not. Okay? I hold the zip grade app in my phone over the test sheet. It tells me how many are right, and I go, good, and I move on. Okay? I am not looking for this. This is just wrong. And that's what my phone will tell me when it scans the sheet, that this is just wrong. And it's right. It's wrong. This is wrong, my phone is right. Okay? Yeah, don't do that, okay? Because it just doesn't understand that. All right? And not that anyone would do this, but because I've had people do this before. As we're going through the test, they're like changing the answers. And then they come up and go, Mr. Coder, I think your phone marked this wrong. My phone takes a picture of every one of these tests when it scans it. So I can just go back and go, uh-huh. Liar, liar, pants on fire. Okay? Yeah. Because I wasn't born yesterday. There's a lot of gray here. Clearly that's not the case. Okay? All right. Not that anyone would do that, but people have tried it. We're ready for that. Okay. All right. That's what's on there, guys. Okay? Let's talk specifics here. Okay, the specifics are, there are 17 multiple choice questions. In the multiple choice, I will be asking about the following things. Scalar versus vector quantities. Okay, that's going to range from things like, which of the following is a scalar quantity, or which of the following is a vector quantity, or I give you a situation like a person walks down the hall and then they turn around and come back. What's their displacement? Okay, like simple calculation kind of stuff to do with scalar versus vector kind of questions, kind of situation. Okay. There's some kind of wordy problems, but they don't involve. They seem like they involve calculations, but they don't really if you read them carefully. You could certainly solve them by calculating, but it's much easier to just read the question carefully. Okay. Then there's some graphing questions, as I said. There's 2, 4, 6 questions on graphing in the multiple choice. Okay. And these are either incredibly simple calculations or their interpretation. Here's a graph, what's going on kind of questions. Okay. question about accelerated motion, and a question about how we do vector addition. It's not a vector addition problem, it's a question about method, so it doesn't involve calculation. And then there's a couple of questions about the principles of projectile motion. Again, no calculation, just the principles of projectile motion. Okay, and then there are 7 written response problems. Okay, question number 1 in the written response, as I said before, horizontally projected projectile. Question number 2, projectile projected at an angle. And as I said, those 2 questions are exactly like 2 questions we have done as examples in class. Question number 3, boat question. Question number 4, acceleration problem. Question number 5, a graphing question. That graphing question has 3 parts. Question number 6 is your vector addition question, so the vector components question. Question number 7 is another graphing question. It has 5 parts. Okay, that gives you a pretty good idea of what you need to study, I would think, yes?
What was number 1 and 5?
1 is a horizontally projected projectile, and 5 is a graphing question. Okay, if you want to have a little bit of extra time to work on, if you have an accommodation for extra time, and you know that, obviously you'll get your extra time. But if you want a little bit of extra time, then come in at lunch. Okay, we'll say at noon. Give you an extra 20 minutes. Okay, so if you want to start a little bit early, I'll let you start 20 minutes early. Okay, come in at noon. I'll let you get started then. Thursday or Thursday. Right, but then that means, guys, that when period 3 is over, you're done. Okay, so you got to keep an eye on the time. Time shouldn't be a factor. Okay, it only took me, I think, 18 minutes to make the key. I figure you guys should take between 3 and 4 times as long to do the test as me. Okay, that fits nicely in an 85-minute period. Okay, questions from you guys? Anything you'd like me to review in more detail? Projectile. Okay, we're gonna do that on Wednesday too. Right? We still have Wednesday's class where we're gonna work on projectile motion. But I can certainly throw a projectile motion question up here. I have some graphing questions too. Yeah, I figured you guys might want that. That's a boat question. Oh, there we go. There's a projectile motion question. Oh, I erased erased a key piece of information. I forgot to put that on this one. Okay, so here's your horizontally projected projectile question. I don't know if you want it horizontal or angled. Either one? Okay. Object goes off this cliff at 11 meters per second and lands 37 meters from the base. Calculate the height of the cliff. Okay, so on this question here, okay, the two pieces of information that they outright give me are both horizontal. They tell me the horizontal velocity is 11 meters per second. They tell me the horizontal distance traveled is 37 meters. Okay, vertically, I get acceleration, just because I know we're on Earth and it's falling, and I get VI because the object moved horizontally at time 0, so that's 0 meters per second. So that's what I start with. Okay. What can I calculate with my horizontal information? Time, yeah. And so I should do that because time is useful. It goes on both sides. So T equals D over V. That's 37 over 11. I didn't fire up the calculator, so now we have to wait for it. 37 divided by 11. Okay, 3.36 seconds is what we're looking at. Okay, that can come over here. And since I'm being asked to calculate the height of the cliff, I'm essentially looking for the vertical displacement of the object, which I can now find because I have A, VI, and T, and this formula will use all three of those things to calculate the displacement. Okay, so I just have to plug in my numbers. Okay, this is 0, so it's just 1/2 times 9.81 times 3.36 squared. All right, so we're looking at a height of 55 meters. Okay, ready to run with that one? So that's a pretty typical projectile question. All right, what do we want to do next? Graphing, I figured. Okay, let's say, okay, so I would like you to calculate for me 3 things. Average velocity over the whole trip. Total, not displacement, total distance over the whole trip. Average speed over the, I keep drawing an arrow, average speed over the whole trip. Okay, what's the average velocity? You should all have it done. 0. Yeah, starts at 5, ends at 5, total displacement 0. Average velocity 0. Okay, so here's things, guys, that are important on a test. If you're finding you're running out of time, it's little things like that that cost you. I will often see on a question like that, somebody do 5 marks worth of work for 1 mark. Okay, that's a recognition question. I got to be able to look at that graph and know I have to do absolutely nothing to do that calculation. And it should take me 10 seconds. Okay? The other stuff, yes, there's more to do with that. Okay? But if I'm well prepared, those are the things I recognize that save me time on a test. Okay? All right. Now you can do the ones that take longer. I'll give you a little time. So if I want to calculate the total distance, does it care which direction I go? No, it's just about how far in each section of this graph does the object travel. So it goes from 5 to, I would say that's about 18, okay? From 5 to 18, so that's 13 meters there, okay? And then it goes all the way down to, looks like -9. Okay, so from 18 to -9 is going to be 27 meters. All right, then it goes another 9 meters here, from -9 back to 0, and then it looks like it goes another 5 meters here from 0 to 5. Okay, so we got 40, 49, 54 meters. On a test, I'd have better grid lines, so you wouldn't be having to estimate, but okay, as long as you got something close to that. Okay. All right, now to get average speed, how do I do that? Right, total distance over total time, 54 over 10, okay? We're looking at 5.4 meters per second as our average speed over the whole trip. Oh, sorry, it's over 30, not over 10. My bad. Absolutely, it should be over 30 because that's what the graph goes to. But now I can't do it in my head. It's going to take longer. 54 divided by 30. 1.8, how's that? Meters per second. Do I need a direction? Then I better not put one on there because it's a scalar quantity and that would make it wrong. So don't. All right, everybody okay with that graph? Okay, I wouldn't ask you anything more difficult than that on the test. Okay, for position versus time graph. Okay, so let's say, let's have you do this one. All right. So here's a velocity versus time graph. Okay, the equation is there. I just wrote it bigger because it was small and it was hard to read. Okay, so it's 2.3 times x. Whoops. Let's just write it bigger so you can see it better. Okay, so y equals 2.3x plus 4.63, and here are the things I'm going to want. Total displacement to 30 seconds, and acceleration, and that's it. Those are the two things I want. Okay, what's the acceleration? 2.3 meters per second. Again, that's one of those things that can save you time. Okay, if you look at this graph and go, oh, that object's accelerating and it's showing change in velocity over change in time, the slope is the acceleration, that saves me time, right? Rather than actually doing a calculation that I don't need to do and shouldn't do, okay, I should just recognize it's 2.3 meters per second squared. Okay, now, here's the problem on a test. I will ask that exact same question on a test, and people will go about trying to solve it, finding numbers to solve it with. Will those numbers give me 2.3? Not a chance. I'll make sure of it. Okay, I will set up the graph so that if you go looking for points on the graph to solve that with, they will not arrive at 2.3. Okay, so make sure you understand how a graphing equation can work and serve you on a test. All right, give you a few more minutes for the displacement. Okay, so using that formula, I'll get the area of those two shapes very quickly without having to do any other calculations. Okay, I'll arrive at my displacement answer. So displacement for this one, right, will come out to, so we get 4.63 times, what do we got for time here? 30 seconds, right? Well, that's not what I want. Okay, times 30 plus 0.5 times 2.3 times 30 squared. All right, so I'm looking at 1173.9 meters. Okay, so that's one way to do it. The other way to do it would be to actually figure out what these shapes are, okay, and calculate their areas. Well, the only trick to that is there's one extra calculation. I need to know what the height of this triangle is by calculating where the line is, what the y value is here at time 30 seconds. That's fine, I can use this formula to get that. Okay, it'll calculate y if I plug 30 in for x. Okay, so we'll have 2.3 times 30 plus 4.63. Okay, so it's 73.63. Actually, adding that 4.63 kind of wastes a bit of time for me. I only want the height of the triangle, not all the way from the x-axis, agreed? So I actually want to just subtract the 4.63 from that. There's the height of my triangle. Okay, now that I have the height of my triangle, I can go base times height divided by 2. There's the area of my triangle plus the area of my rectangle, 4.63 times 30. Oh my gosh, look what happened. I got exactly the same answer. Okay, that's not by accident, it's not a fluke either. Okay, all right, is everyone with me on that?
Would it be wrong if you put it in scientific notation?
No, absolutely not. Yeah, you could totally put it in scientific notation. Okay? And in fact, I would say you probably should, given that you only have 2 significant digits on the graph. But on a graph, I never worry about significant digits, just so you're aware. Okay? On a graph. Are significant digits important on everything else? Yes.
Can you use a VI formula if it's not like linear acceleration?
No, this only works on the linear one. Yeah. Okay. What else do we have here? Are we running out of time? We are. We got 3 minutes left. Okay. What if I gave you an irregular velocity graph? Okay. If I asked you to calculate the acceleration, could you still do it? Sure you could. Okay? You could do it by, you could calculate the acceleration in each section, or still even over the whole trip. Okay? This formula still works. If I ask you for the acceleration over the whole trip, that calculates average acceleration. Right? All I do is go, all right, my final velocity is 0, my initial velocity is 4, and that happens over 30 seconds. I can still use that formula. It's just fine to use it there. Okay? And then I would have to calculate all the shapes if somebody wanted the entire displacement over the whole trip. I wouldn't give you one that would have that many shapes on a test because it would take too long. No, this is a velocity time graph. So now you got to do your shapes. Right? Okay, so you got here. This one would take forever because there's a whole bunch of shapes. Okay? All right, that's, what's that? This is final position minus initial position. Right? Okay, so that's the stuff to look at, guys. I think that gives you a pretty good idea on how to focus your studying. Okay? So make sure you do that. The review package is the last couple of pages of your Kinematics digital workbook. Right? There's some old exam questions in there and a key for you to use if you want to. All right, remember guys, next week if you're needing some help, okay, on Wednesday I'm available before school, at lunch, and after school, but Thursday we write the test. And so do my Science 10s. There will be no help Thursday morning because my Period 1 Science 10s will be starting their test early. Okay, so there will be no help Thursday morning.